So let's evaluate now the Laplace transform of 3t squared and the Laplace transform of negative 2t squared. To do this, let us remind ourselves of the Laplace transform of t squared already discussed in the previous video, and this is just equal to twice 2 over s cubed. These were actually generated from the formula of the Laplace transform of any f of t, which is equal to the integral from 0 to infinity of e to the power st f of t dt. So we are going to use the same concept as we move here, but we are going to actually come up with a general form later, and so it would be easier for us to come up with these forms later. So let's have the Laplace transform of 3t squared. This can be integrated into this manner. You will have the formula Laplace transform of 0 to infinity, integral of 0 to infinity of e to the power of negative st. You will have 3t squared dt. Okay, so with that, take note that 3 here is a constant. You can always move that out. You have 3 times the integral of 0 to infinity of e to the power of negative st t squared dt. Okay, so that this video will not be longer, take note that this is actually equal to the Laplace transform of t squared discussed in the previous video. If you're not yet convinced with that, you can also return to that video to understand this, because we were able to use the integration of parts to come up with this result. So what is my point here? Since it's just the Laplace transform of 3t squared, okay, Laplace transform of 3t squared is just the result of 3 times this expression. So simply multiply the equivalent of that, so that would be 3 times 2 over s cubed. That's cube. Again, cube, yeah, cube. In short, the Laplace transform of 3t squared is just equal to 6. That's 3 times 2 over s cubed. Okay, so this is just the result for our Laplace transform of 3t squared. Ultimately, you will have here the Laplace transform of negative 2. Sorry, this should be a brace. My bad. This should be a brace. Negative 2t squared. Similarly, this is just equal to what happened here is just it would be the Laplace, the integral of 0 to infinity of e to the power of negative st. And you will have here negative 2t squared dt. As mentioned, you can always take out negative 2. You will have here 0 to infinity, the integral of 0 to infinity e to the power of negative st t squared dt. Again, this is just equal to 2 over s cubed. Hence, this is just equal to negative 2, or the Laplace transform of negative 2t squared is just 2 times 2 over s cubed. This is equal to negative 4 over s cubed. So with these results, we can now generalize the Laplace transform of any constant c t squared. Okay, for any c, just like here you have negative 2, earlier you have positive 3. Here you will also come up with 1, actually 1t squared is just equal to actually c, whatever that c is like here, negative 2 times this, times 2 over s cubed. Let's look at this one here, 3. So 3 times 2 over s squared. Just like here, 1. So it's just 1 times 2 over s cubed. So here, this is just equal to 2c over s cubed. This should work for any constant c. So take note of this, because as soon as we come up with other forms, we simply plug in the c that is found beside t squared and simply plug it in to get the Laplace transform. Okay? Thank you very much for watching.